Okay, in this section, we're going to continue talking about polynomials, and you're going to be asked about finding the roots of polynomial equations. And one thing that you've got to keep in mind is that whether they're asking you to get the solutions or the answers to a polynomial, or the zeros of a polynomial, or the roots of a polynomial, it's actually all the same thing. You would actually go through the same process to determine any of these. It's kind of how the problem is set up will kind of depend on what word they use, and that's not something for you to worry about because you just need to know how to do the process to find these, and the process is exactly all the same. We talked about zeros earlier in chapter 5, whereas these couple of sections concentrates on using the word roots. Okay, so first we're going to look at what is called your rational root theorem, and this is going to give you a list of possible rational roots. So since this specifies rational, this is just a certain type of number. This would be any number that could be written in the form of a fraction. And what it means by just possible roots is not everything in this list are going to be actual roots or actual answers. And that's what we're going to end up figuring out. Once we get this list, then we're going to look at, well, how do we know which ones are actually the real roots? Okay, it uses the letters P and Q to represent two things here. So what I want you to remember is that P is always associated with the constant term, and Q is always associated with the leading coefficient. And what you're going to want is the factors of the constant term and the factors of the leading coefficient. Now, once you identify all of this information, then you're going to go through and make all of these different fractions that you can make by using the numbers from your list of P as your numerator and the numbers from your list of Q to use as your denominator. So you'll see how all of this works, but just remember, of course, that P is associated with the constant term and Q is the leading coefficient. Okay, so for this particular example, to get the list, okay, so I'm going to refer to P and Q. So P, as I had stated, is the factors of the constant term. If you remember, your constant term is the term that doesn't have the variable, in this case, the negative 15. Now, if I want the factors of negative 15, that means I want all the numbers that will go into negative 15. And actually, it doesn't matter whether this is positive or negative 15, because when we list all the factors, we're going to list positive and negative anyway. So we know that 1 will go into 15, and again, you're going to include positive and negative 1, so just put the plus minus. Okay, the next number that'll go into 15 is 3, and again, you're going to include the positive and the negative. Next number that will go into 15 will be 5, include positive and negative, and the last factor of 15 would be 15 itself, and again, include positive and negative. So you're going to put plus minus every single time, whether this is a positive 15 or a negative 15. Okay, Q was referred to as the factors of the leading coefficient. Your leading coefficient is going to be the number in front of the x that's got the biggest exponent. So typically it's the first term, but it doesn't have to be. It just is most of the time. So in this case, my leading coefficient is going to be the 3. And then I've got to list everything that will go into 3. Well, the only thing that will go into 3 is going to be 1 and 3. So now we've got to make this fraction that I was talking about. We've got to put all of the P's over all the Q's. So just kind of a systematic way that you can do this each time. I just start by putting 1, 3, 5, and 15. I put all of these numbers over the 1 first. So 1 over 1 would just give me 1. 3 over 1 would just give me 3. 5 over 1 is just 5, and 15 over 1 is just 15. But now I've got to put them all over 3. So I would put the 1 over the 3, so that means I'm going to have a 1/3. Now when I put 3 over 3, 3 over 3 reduces to 1, and you already have it in your list, so you're not going to bother writing it multiple times. Next would be 5 over 3. So we'll have to add this onto our list. And last is 15 over 3, but 15 over 3 reduces to 5, and you already have it on the list. So when they ask you to get the list of possible rational zeros, this is it. Okay? Now, you're going to have to do this list, come up with this list for most of your homework problems. Okay, so this will be something that you'll definitely get plenty of practice on. And you'll see me do more of these as I do the other examples.